In this next part, let's take a look at trapezoids. Problem 1 here, we've got in this isosceles trapezoid, ABCD, and we're given angle A is 124 degrees. So isosceles trapezoid. Trapezoids always have one pair of parallel sides, and then we're also told that it's an isosceles trapezoid, so I'm going to mark these sides as being congruent. Now, A is 124, so I throw in 124 degrees there. Since it's isosceles, I know that this is going to be the same over here, because isosceles trapezoids do have symmetry, so they do fold in half. The other thing I know is that I have same side interior angles. If I were to extend these parallel lines here and then draw myself a transversal going across, I know that I'm going to be able to get same side interior angles between the 124 and then angle D. So those two have to add up to 180, and 180 minus 124 is going to be 56. So I get 56 degrees down here. By symmetry, I also get it over here. So 124 and 56 are the angles that end up making up the four corners. Moving down to the mid-segment of a trapezoid. It's kind of like the mid-segment of a triangle. If we remember when we had mid-segments of triangles, you ended up having to find the midpoint of one side, the midpoint of another side, and then connect it with a mid-segment. And with a triangle, if we had, let's say, 10 down here, the mid-segment would be length 5. It would be half as long as the base. One way I also like to describe it is, well, let's say the top is a point, so that's a side length of 0. And so really we just took the average of 0 and 10 to find our 5. Within a trapezoid, we have a similar concept, except the top is not going to be 0. The top of the trapezoid might be a number. So let's say it was the number 6, and we had the number 10 on the bottom. So instead of just cutting 10 in half and calling this 5, we're not going to do that. We're instead going to say, well, what's the average of 6 and 10? 6 plus 10 is 16, divided by 2 is 8. And we know that 8 is halfway between 6 and 10. So the mid-segment would be a length of 8. So that's what a mid-segment is. So let's do this first example here. We have a trapezoid. When we see on the side that we have equal parts for this, and we know this is the midpoint, we have equal parts here, so we know that's the midpoint of that side. It's kind of the opposite of the definition of a midpoint that we're used to. We have the equal parts, we get the midpoint. So that means this mid-segment going across here is going to be the average of 11 and 17, our base and our top. So we add those two together and we get 28, and then we divide that all by 2, and we're going to get 14. And we know that 14 is halfway between 11 and 17, so that makes sense. Last one here, we're trying to find what x is. And we know that 7 is the average of 10 and something. Now there's a couple ways to go about it. I'm going to show you both ways real quick. The way I would probably do it is say 10 plus what divided by 2 is equal to 7. Well, I multiply both sides by 2 and I get 10 plus what equals 14. Take away my 10 and I get my mystery is 4. So I know that this base overall is going to be 4. I can then set that equal to 2x, and I can divide both parts by 2, and I end up getting that x is equal to 2. So that's one way I could do it. Another one would, instead of putting question mark up here, I could have directly put in a 2x. So if I just directly put in 2x here, it would save me a step later on, and then I would know that 2x equals 4 divided by 2, x equals 2. So a couple different ways to approach it. It just depends on how you like to work with it, but it's going to get you to the same place. So for this one, what is x? X is 2.